Thank you for attending our digital trade show. We invite you to ask questions via the chat feature on the right side of your screen. If you don't see this feature, click on the green tab at the top of the screen and select Chat from that menu. We will answer questions live. For some of them, we may have to follow up after the session. Today's session is related to our Nexus and Lamina inserts in high-temp alloys. The presentation will take approximately 20 minutes. I'm Trent Moss, National Sales Manager for Techniks' new cutting tool division, Nexus Cutting Tools. Today I want to introduce you to Nexus, our insert manufacturing partner Lamina, and discuss how our products can help make you more profitable and productive in machining high-temp alloys. We're focusing on high-temp alloys because it's a particular strength of ours and also a particular point of frustration for many customers. High-temp alloys are very popular in aircraft engine components, industrial gas turbine components, petrochemical, oil, and biomedical applications. They perform excellent thanks to their resistance to heat, corrosion, and stress. As with many good things, however, there are trade-offs for the benefits. In this case, there are two specific trade-offs. One, high-temp alloys are an expensive material to purchase. Second, they pose significant challenges in the machining process. This causes increased concerns because the price of scrap is so high with these materials. Let's take a closer look at how Nexus can help you improve confidence, productivity, and reduce scrap while machining high-temp alloys. I'll start with a short example from one customer. His name is John. What does 3 parts per edge mean to you? Probably not much. To John, however, 3 parts per edge was a problem, although a common problem for those that dare machine in the realm of high-temp alloys. To Nexus and Lamina, we saw 3 parts per edge as an opportunity. This was more than an opportunity to sell John a single WNMG insert. This was an opportunity to show that Nexus and Lamina is far more than a geometry, chip breaker, and a coating. We have a totally new concept that allows machinists to expect more from their indexable cutting tools. Our opportunity is to help improve manufacturing with a product that will increase metal removal rates, decrease cutting time, reduce inventory costs, and simply stated, turn your business into a more efficient and simpler manufacturing machine. John was given a job that required him to machine 2,000 parts out of Inconel 625. After going through the testing process, he decided to use a WNMG insert with a specific high-temp coating from a well-known and highly respected cutting tool manufacturer. This specific insert allowed John to get 3 pieces per edge, or 18 per insert. John knew that he could complete his commitment to the job with this insert. He could even make money. However, John had a burning curiosity to find more productivity. He contacted us based on our reputation for performing well in high-temp materials. John allowed us to test our WNMG insert against the respected competitors. The results were staggering. While decreasing cutting time by 15 minutes per part, we were also able to increase part production from 3 parts per edge, or 18 per insert, to 14 parts per edge, or 84 parts per insert. Taking into account that this was a 2,000-piece job, John went from a projected 17 boxes of inserts from the competitor to only 2.5 boxes from Nexus. That's the photo that I'm showing on the screen now with the test and productivity results. The competitor in red on the left, the lonely Nexus blue boxes on the right. Stay tuned to see how we accomplish this for John and how we can do the same for you. Here's a brief agenda for our time together today. First, I'd like to talk a little bit about our philosophy as a company. Then we'll discuss the eternal question, what's new? It comes up everywhere we go. Then I'd like to get very specific and describe the 3 main challenges of machining high-temp alloys and how Lamina addresses them. Finally, and most importantly, The reason we're here is to talk to you, and we'd like to discuss how we can work together with you to test these solutions in your applications. For over 15 years, Techniks has helped customers with innovative approaches to the CNC world, focusing mostly on the tool holder connection. We've based every product in our 300-page catalog on one simple principle. For every 1/10 of runout, the customer will lose 10% of tool life. Applying this principle to end mill holders, collet chucks, etc., has helped set us apart from competitors and earned us a reputation for excellent quality. Our focus is always on rigidity and accuracy. This is why one of our most successful marketing slogans is "Success depends on every component." Tighter bore tolerance in end mill holders, ultra precision collets, power coat nuts for collet chucks. Not exciting, but simple, innovative, and very effective. I wish I had a nickel for every time a customer has looked at one of our new products and said, "Why didn't I think of that?" Along the way, we saw an opportunity to help customers by providing magnetic work holding solutions too. Since then, we've helped save thousands of customers time and money by showing the enormous advantages of magnetic work holding over traditional vices and clamps. And we don't stop there. We're always looking for new ways to help our customers. Everywhere we travel, trade shows, manufacturing plants, open houses, we get the same question: what's new? Especially after the economic challenges from very recent memory, American manufacturers seem more determined than ever to find new ways to gain competitive advantage. Reshoring American jobs is now as common a conversation as offshoring was just a few years ago. This is a good thing. We're a company that thinks differently, and we think we can bring a helpful and a new approach to the way that customers use carbide inserts. Additionally, we're leveraging our expertise in tool holders to create high-performance face mills, indexable end mills, turning tools, boring tools, and indexable drills. In fact, we have several new patents designed to improve rigidity and accuracy in holding the tools. The first of these is our shrink mill system. We're the first company to apply heat shrink technology to a face mill. This is our shrink mill system and reduces runout by as much as 30%. The second new patent is the power lock system. Our power lock system transforms a standard Techniks collet chuck into a high-performance milling chuck by simply inserting a small square shank adapter into the collet chuck. This female adapter engages with the male end of our end mill holders, which translates to virtually unlimited holding power, giving you the accuracy of a Techniks collet chuck at half the price. Before we get into any technical conversation, it's important to know a few facts about the way that people use inserts. This may be surprising to some of you, but these facts are taken from a study sponsored by Makino Machine Tools. The first of these is that half the time, inserts are selected incorrectly for the machinist application. The second is about half the time, inserts are applied incorrectly based on the manufacturer's recommendations. And finally, again, about half the time, the inserts are discarded and tossed before they're fully used. So obviously something is out of whack, and we saw this as an opportunity to help customers. So the next logical question then is, why Lamina? Why did we select Lamina as our partner? We did a lot of research, interviewing, and due diligence in our search for a manufacturing partner to make our carbide inserts. Eventually, we arrived in Switzerland at Lamina Technologies. First, Lamina met our criteria for quality. Swiss quality is a phrase that still carries a lot of credibility, and Lamina lives up to that billing. One small example is that within their insert batches, tolerances are held to plus or minus 5 microns. Second, they match us philosophically. Lamina challenges the status quo. They want to offer simplicity, particularly to the small and the medium-sized shops, instead of the typical new grade offerings that customers are conditioned to expect a couple of times a year from the major carbide manufacturers. Most importantly, though, Lamina uses common sense in developing their products and serving their customers. Like us, this means simplicity, predictability, and responsiveness. So let's get specific about high-temp alloys now. I'm going to review 5 ways in which Nexus and Lamina work together to address these challenges. Based on our expertise as Techniks, we understand the importance of the best tool holder for the job. Lamina starts with a submicron carbide powder using no cobalt enrichment. This helps to resist the compressive forces typical of cobalt-enriched inserts. More on this later. Lamina's unique edge preparation is a complete departure from the traditional brush honing technique. Instead, Lamina uses a micro sandblasting technique that allows tolerances of plus or minus 5 microns. This precise honing allows for extremely sharp geometries, even with Lamina's substantially thicker PVD coatings. Note in these graphics, with the competitor on the left and Lamina on the right, that the 2 blue circles represent a perfect angle. The red arc represents the actual edge of the insert. The closer that the actual edge follows the perfect circle, the more precise and consistent the edge geometry. The differences are dramatic, and this translates directly to performance in machining. The 4th engineered difference is the PVD coating. Lamina's proprietary PVD coating provides both heat resistance and toughness. Lamina's scientists have developed a proprietary PVD coating that is 2 to 4 times thicker than their nearest competitor. These coatings dramatically increase the insert's overall life and performance. The coatings are accompanied by sharper geometries, thanks to the precise honing technique that we described. Customers experience far less downtime and gain productivity at a pace that many thought was unachievable. The 5th and last important method of attacking high-temp alloys is Lamina's NX chip breaker. This NX chip breaker is perfect for the ductile and gummy challenges of high-temp alloys. This innovation provides a fully positive rake angle, precisely positioned deflectors, and a post-coating surface treatment to reduce friction and enhance chip evacuation in abrasive materials like high-temp alloys. Here are some of the most common examples of the family of high-temp alloys. Next, we'll take a look at the specific challenges and how we address them. In truth, high-temp alloys are very similar in challenges to stainless steels. The problems are only exaggerated and thus accelerate carbide wear dramatically. Due to the gummy nature of high-temp alloys, the material tends to work harden during machining operations. And that's what I'd like to focus on as the first challenge in working with these materials. Work hardening keeps the heat in the workpiece and in the cutting tool instead of being evacuated with the chips. Typical inserts will fail due to plastic deformation in these circumstances. This common failure example may look familiar on the screen. Still talking about work hardening, some customers will naturally slow down on feeds and speeds to help address the problem. However, the operator who overcompensates for high heat by slowing down too much, which is very common, will experience a different type of failure known commonly as built-up edge. In other words, you usually have a choice between 2 premature failure modes, neither of which is a good option. To further illustrate this phenomenon, Lamina conducts their own in-house testing. I'd like to share one of these tests with you. For our internal test, we ran a 7.5-minute milling application on Inconel 718 using both our APKT 1003 versus a well-known competitor's grade made specifically for Inconel 718. The test parameters are as shown on the slide and were held consistent for both inserts. The results again on the next slide will speak for themselves. Obviously, on the left, the competitor's insert is experiencing the failure of plastic deformation. And on the right, the Lamina insert still has lots of life in it. In fact, take a good look and you'll see that that insert is just getting started. So the question is, how does Lamina do this? How do they avoid the plastic deformation that happens to so many other inserts? First, that NX chip breaker. Remember, it provides a fully positive rake angle and the superior honing technology to easily cut the gummy material, because that's what it was made to do, work in these types of materials. Second, the PVD coating greatly reduces friction. Combined, these two unique features produce less heat and better chips, extending your tool life. Incidentally, Lamina inserts like to take heavy depths of cut, and this increases your productivity even more. The second challenge we're going to talk about is the fact that high-temp alloys have poor chip breaking properties. This is due to their ductile nature, often described as gummy or sticky. In most inserts, high-temp alloys produce undesirable long and stringy chips. This is what keeps heat in the workpiece and the cutting tool. This leads to the insert failure mode of plastic deformation that we described earlier. Jobs cannot be left attended because the operator has to manually remove chips after each part. What we all want are chips that look like 6s and 9s. Lamina helps to accomplish this in two ways. The first is the edge preparation. The heat is reduced, better evacuated with the proper chip formation, and the operator is free from monitoring the machine and clearing chips constantly. The second is Lamina's NX chip breaker. Again, we remind you of the positive rake angle, the deflectors, the surface treatment. This reduces friction too, breaks up the chips, and greatly enhances chip evacuation. The last of the three challenges of high-temp alloys we're going to discuss today is the abrasive nature of the material. Compared to other materials, high-temp alloys also challenge the cutting tools with their very abrasive nature, leading to greatly diminished tool life and downtime. This is seen in the insert as notch wear failure. This problem causes a lot of downtime to change inserts. If not detected in time, notch wear can lead to catastrophic failure of the insert or total loss of the insert corner. Lamina's solution to this problem is a combination of two things. Again, the PVD coating. This thicker coating allows significantly more wear resistance in the abrasive material. Combined with Lamina's investment in even more time and money here in the post-coating treatment, this delivers a product that resists friction and wear. Post-coating treatment is another proprietary process from Lamina. For this final section of our presentation, I'd simply like to share a couple more real-world examples of customers who made dramatic improvements by switching their high-temp alloy application to Nexus inserts. In this first example, the customer was machining titanium alloy and actually was pretty happy with this 5 parts per edge from the competitor. That is, until he gave us a try. It did not take long to see his productivity pick up at a noticeable pace. These numbers reflect a 340% increase in productivity based off of insert consumption alone. The blue numbers on the right at the bottom of the screen represent 102 parts per insert, up from 30 that he was experiencing with his previous provider. This last customer was machining titanium alloy and had tried several competitors before settling on one who helped him to get to 4 parts per edge, or 16 parts per insert. You'll see in the red. After our testing, however, his expectations are now 250% higher. The laminate inserts are generating 40 parts per insert compared to his old standard of 16. And we get what we like to see, and that's a happy customer. As a quick review, lamina is engineered from the beginning to perform in high-temp alloys. Techniks adds value by applying the proper tool holder technology to the application. And as we showed you with 3 of our customers, the results speak for themselves. There's a lot of red boxes on the screen and very few blue. As far as our presentation goes, that's the end. And now we'd like to have a chance to work with you. Please contact us with questions and test opportunities. We'll do all the work. Everybody have a great day. Thank you.